Find dy dx if y minus e to the x plus 3 equals x squared y. Right, finding dy dx means find the derivative. I'm going to have to use implicit differentiation on this one. The derivative of y would just be 1, but I do have to include the dy dx. And then minus the derivative of e to the x is just e to the x. Remember, e to the x is its own derivative. The derivative of 3 is 0, and then equals. I do have a product on this side. I have an f and a g. F prime would be 2x, g prime would be 1 dy dx again. And let's see here. So we're going to use the product rule, f prime times g, so 2xy plus f g prime x squared dy dx. And I would like to solve this for dy dx. So I'm going to subtract this over there, and I'm going to add this over to this side. I will have 1 dy dx minus x squared dy dx equals 2xy plus e to the x. Okay, the next thing that I would like to do is factor out a dy dx, and so I'll get 1 minus x squared equals 2xy plus e to the x. And then to get dy dx by itself, we'll just divide both sides by 1 minus x squared. So we'll get dy dx is equal to 2xy plus e to the x all over 1 minus x squared. Okay, problem 8. Find the derivative once again. We know that f of x is equal to x to the 5th times e to the 2x minus 3. Again, this is a product, so I'm going to have to use the product rule. F prime, the derivative of x to the 5th, is 5x to the 4th. And then I do notice for the g, I have an e. We know that the derivative of e to the u is just e to the u du. So the derivative of e to the 2x minus 3 is just e to the 2x minus 3 times the derivative of 2x minus 3, which is 2. So I'm going to rewrite this as 2e to the 2x minus 3. All right, applying the product rule now, we just get f prime times g plus f times g prime 2e to the 2x minus 3. Okay, and then I'm going to look at what I could factor out. I notice that they both have an x to the 4th, and they both have an e to the 2x minus 3. So if I factor that out, I'll be left with 5 plus, I still have my 2, and I still have one of the x's, and that is it. That will be my derivative. Okay, number 9, solve the differential equation dy dx equals e to the square root x over square root x. Okay, on this one, if I want to solve a differential equation, instead of having the derivative, I just want to have y, and we know to get rid of a derivative, we're going to take the integral of both sides. All right, and I notice I have quite a bit stuff going on the right side. However, I'm going to use my hint that when I have one e in the problem, we will let u equal the exponent. So even though I'm not sure what's going on, I'm going to let u be the exponent. Another way of writing that would be x to the 1/2. To get the derivative of x to the 1/2 would be 1/2 x to the negative 1/2. And if I rewrote that without a negative power, I'd have 1 over 2 square root x. Okay, I notice that I have the square root of x on the bottom. I'm just missing the 1/2. So if I put a 1/2 on the inside, I have to put a 2 on the outside. So I'm going to have y equals 2. And then I have done nothing with the e, so my e is still there. The square root x turned into u, and everything else actually turned into du. And we know that the integral of e to the u du is just e to the u. It's its own integral, and it's its own derivative. So we'll know that y is equal to 2 e to the u, which is e to the square root of x, plus c. Okay, problem 10. Evaluate the integral of e to the 3x over the square root of e to the 3x plus 4. Okay, if there's more than one e in the problem, we will let u be a bigger chunk. I'm going to let u be e to the 3x plus 4. I'm not going to involve it with the square root right now, just the e to the 3x plus 4. Okay, the derivative. The derivative of e to the 3x plus 4 is just e to the 3x times the derivative of the 3x, which would be 3 dx. Okay, I do notice that I have e to the 3x. I'm just missing the 3. So to undo that, I'll put a 1/3 on the outside. So I have 1/3. Okay, all of this stuff right here is a part of du. And then this stuff down here is u, but there's still a square root on the bottom. So that would actually be u to the negative 1/2. Okay, now I'm ready to take the integral. I have 1/3. The integral of u to the 1/2, remember we're just going to increase our power by 1. That will increase it to 1/2. The reciprocal of 1/2 goes on the outside. And so I'm going to have 2/3 the square root of my u, which is e to the 3x plus 4, and then plus c.